Hi my friends, today we model this part. It seems to be simple, but it has some interesting features. For example, you see here a line, also here, also here. The drawing reveals some aspects, you see. We start by creating this contour and using dimensions 22.8, 6, 34, diameter of 20 for this circle, 14.2, radius 5, 25 degrees, and extrusion. New standard millimeters IPT, new sketch, XY plane, circle, diameter of 20, then we draw lines. This is 34. When you can, you place dimensions directly. 14.2, we go down, then we look for the tangency. This is tangency. Good. Other line is horizontal, 22.8, then up on 6, back to the circle, press the left button and go to the circle. Then we place tangency here. This fillet is 3 millimeters. This angle is 25, and we need to place other two dimensions. One of them is tangency here. The other one, I don't know what is, because this is tangent, this is tangent. Maybe here. Let's try. Yes. Now we have a fully constrained sketch. We have to take a look here, because you see 1 degree and 1 degree are dimensions from this face to the right and the same face to the left. We apply firstly this 3.5, which is this feature. Then we'll apply this 4.6 for the other half of this part. Let's do this. Extrude 1, 2, 3 areas, the other direction on 3.5, and we use advanced properties and 1 degree of taper. 1 degree must be placed in this direction or the other direction. Yes, you select which one you want. We want to have a smaller distance here than here, so I show you what happens. We want this solution with minus, my friends. This face will be visible with only one contour, and this face with many smaller contours. Plus, and now we extrude only two areas, this one and this one. The thickness is 4.6, and again we use minus 1 degree to have this other feature. Okay, I want you to see something. Here you see two arcs, and here only one. If I turn back the part, you see here two lines and nothing else. Good. Next is this cylindrical faces. These are conical. Yes, this is conical and these two are cylindrical. Dimensions 1.8, 1.5, 15, 18. We use a work plane, this work plane, F7. We project this face, we draw some lines, 1, 2, 3, 4, and back here. This is a center line, and we have to apply that 4 dimensions mentioned by me before. 1.8, 1.5, major circle is 18, minor circle or cylinder is 15. Fully constrained sketch, revolve. Okay. Now we have to create this extension, and you see here only one face. This is the other face. In other words, you see here this edge to separate the two extrusions, and we apply now this extrusion 1.4 with 8, and the dimension is also 6, or what is there, because if I extend this, we see that this is not 6. Yes, this is a smaller value. Okay, this is the face, a new sketch. We project this. It means that this is smaller than this. Then rectangle, starting from this corner to the other edge, and with a dimension of 8. we ignore this dimension because it is a result. Finish sketch, extrude this on 1.4 millimeters and also 1 degree with minus. Now you see this is a line to be up. If I change this, it comes to be down. Okay, all faces are respecting this solution. The other extension is similar. 4.1, 0.5. We select this face. We apply a sketch. We create a sketch. Then we project the face because we want to create another rectangle with this bottom dimension of 4.1. The other is taken from here. Finish sketch, extrude this face plus or minus 1. You see, now it is in the other direction. Now is okay, minus 1 degree. Okay, very good. I'm here and I apply 5 here because I don't want to forget it. You see here that 5 fillet. On the other face there is an extrusion with this dimension, diameter of 15, radius of 9, 26 degrees, 90 degrees, and the extrusion is on 1.5. Let's do this. Sketch. We have the center. I don't project anything. I draw a circle of 15 and another one with a radius 9. I draw a line from this point to the external circle at an angle of tab 26. Another line is here, and we also use 26 plus 90 dimensions in the drawing, my friends. I place them outside to be more clear. This is 1/16. It is not in the drawing, and I apply 90 here. You have to respect the drawing always. Then I apply trim to cut this arc and this arc. I don't care if these are placed inside, because we can apply extrude on 1.5 for this and this. 1.5. Okay. Next is this extrusion with dimensions from the drawing. Radius 3.5, 30 degrees, 8.5, 8. Good. We select this face. We draw some lines, but let me project all the face, no problem. And lines are horizontal. Press the left button of the mouse and go here, then tangent, then press the left button and go to the line. Apply tangency. Then dimensions. This is 3.5. This is an angle of 30. Dimension of 8 to that arc, 8. The other dimension of 8.5. And this arc is 2 millimeters because we see here undimensioned fillets are radius 2. This is an undimensioned fillet. What is the extrusion? 5.5. And you see here a chamfer of 2 millimeters. This chamfer. Finish sketch. Extrude. These at 5.5. Then that chamfer of 2. Okay. You see here 2 at 45. Another interesting feature is this cut a square of 7 through the part, but from this line it goes to 2 degrees taper, and from this is also 2 degrees outside to this bottom face. This is with one direction, and this is with other direction. Yes, we have to be careful with this. But this line, where is this line? This line is on this face, my friends. This face. Yes. Don't forget, 4 degrees is the angle. We select this face, F7. We use polygon with 4 sides with this center and placed in this position. This dimension is, once again, this dimension is 7, and we project geometry this axis X, but as a construction line to apply that angle of 4 degrees. Finish sketch. Now we work with something invisible. We apply extrude. Inventor found the only close contour, and we select the other face all the way with cut, and placing here 1 degree, not minus 1 degree, plus the same area is selected and also 1 degree. Okay. If you wonder what is this slope face, what is the angle, you can use M from Monaco to select this face and this face, and you see 91 degree, more than 90. This means that this is upper and this is lower. Yes. Another way to measure is this 2 degrees. 2 degrees somewhere very far away. Done. The last thing to do is to respect this. Undimensioned fillets are radius 2. And you see here a fillet. Yes, this one. This is 2 millimeters all around this right edges. I select one of them. 2 is by default. Everything was selected. Okay. Now I see that this extrusion is longer than it should be. It is the same with this. The drawing shows us 1.4, 0.5, and they are here. They are both 1.5, my friends. Double click and 0.5 is the value. Yes, you have this data if you select this option, display preferences, and you check this option, show extended names. If you don't want to see them, you don't have them here. Yes, but I recommend you to use show extended. Now you see here 1.4, 0.5. Now we can try to check the volume. Properties, physical, update, copy, drawing, double click, and the new value is just the same, my friends. Cancel. I don't change this because this is the result also when we made this model. The material is steel carbon. We don't want to see edges, and we select other light, default lights. Now we can compare the two, and we don't see any difference between them. That's all for today. Thanks for watching. Bye bye.